Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of functions. So as per the problem, provide an equation of a function with the following properties, and we are given these three set of properties. For this problem, there can be multiple answers for these functions. So let's start with part A. As per part A, the domain of the function can be any real number less than or equal to 2. The range can be any real number less than or equal to 3. The interval of increase is from negative infinity to positive 2, and there is no interval of decrease. Let's start by sketching this information. The domain is any real number less than or equal to 2. That means the graph of this function is on the left side of 2. The range is y is less than or equal to 3. Therefore, the graph must be below or equal to 3. This function increases from negative infinity to positive 2. That means as we go from left to right, from negative infinity to positive 2, the function value or y value should increase. This function has no interval of decrease. So this function can be a square root function because square root function can only have an interval of increase or decrease and not both. So a possible sketch for this function is, so it starts at 2, 3 and goes down on the left side. So this can be the possible graph for this function. Now we can write the equation for this function. So let's start by writing the general equation of a transformed square root function. Different teachers use different letters for A, B, H, and K, but the resulting transformations are the same. If we compare this graph with the graph of the base or the parent function for the square root function, we can see that there is a reflection over the x-axis and reflection over the y-axis and vertical and horizontal translations. So a value can be equal to -1, b can be equal to -1, h is equal to 2 because there is horizontal translation 2 units to the right side, and k is equal to 3 because there is vertical translation 3 units up. Now we can sub in these values in the general equation. So this can be the equation of this function in part A. Now we can answer part B. The domain is any real number. Range is any real number less than or equal to -4. Interval of decrease is from -1 to positive infinity, and there is a turning point at -1, -4. So let's start by sketching this information. There is no restriction on the domain. Range is y less than or equal to -4. There is a turning point at -1, -4. So this can be the turning point. There is an interval of decrease from -1 to infinity. That means from -1 to positive infinity, the graph should go down because the y value or the function value should decrease. Since this function has a turning point, one possible function that satisfies these properties is quadratic function The graph of a quadratic function is a parabola and it has a turning point. So we can sketch the graph like this. So the graph is going down from -1 towards positive infinity. Since there is a turning point at -1, 4, that means the graph should be increasing from negative infinity to -1. So this can be the sketch of the function. Now we can write the equation for the function. For this quadratic function, we can use the equation in vertex form. This parabola opens in the downward direction, so a can be equal to -1. There is a horizontal translation, 1 unit to the left, so h is equal to -1. And there is a vertical translation, 4 units down, so k is equal to -4. Now we can sub in these values in the equation. X minus -1 is equivalent to x plus 1. This can be the equation of the function for part B. Now we can answer part C. Decreasing on interval -infinity to 1 and from 1 to positive infinity, no interval of increase. As x approaches positive infinity, y approaches -2. This last property suggests that there is a horizontal asymptote in this function at y equals -2. So we can use a reciprocal function for part C. There must be a vertical asymptote at x equals 1 because the intervals of decrease break up at x equals 1. So let's start with a sketch for this function. The horizontal asymptote is at -2. The vertical asymptote is at 1. In this function, there is no interval of increase. That means as we go from left to right, the function value or the y value should decrease. As we know, the graph of a reciprocal function is drawn in the form of two curves. So as we go from left to right, the two curves should go down. So we can draw the first curve like this, and the second curve can be drawn like this. In the graph of parent or base reciprocal function, the curves are drawn in quadrant 1 and quadrant 3. That means this function has no reflection in the x-axis or y-axis. Next, we can write the general equation of a transformed reciprocal function. Since there is no reflection, a can be equal to 1, b can be equal to 1. There is horizontal translation, 1 unit to the right, so h is equal to 1. There is vertical translation, 2 units down, so k is equal to -2. Now we can sub in the values in the general equation. So this can be the equation of the function in part C. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.